Okay, so today we're going to talk about hyperbolas, something new to you. Ellipses and hyperbolas go together. Now notice a difference. We saw the word foci involved, okay, just like we had in ellipses and in parabolas. But here's the major difference. Two major differences between the equations of hyperbolas and ellipses. First, c squared equals a squared plus b squared. Remember, for an ellipse, it's c squared equals a squared minus b squared. And secondly, there's a subtraction sign in between the quantities. Now, for whatever reason, they didn't go ahead and put in the x minus h quantity squared and y minus k quantity squared. That should be there as well to get your center. Okay, even though it's technically not a center, but it is a center point. Okay, now an ellipse, you're going to end up drawing a box, dotted box like this. Okay, an ellipse are basically two parabolas. If they open left and right, they open left and right. So this thing going to go through these two vertices, or they'll be. So that's if x squared is first. So if it's x squared minus y squared, then it's going to open left and right like this one. Okay. If it's y squared first, then it's going to open up and down. And these are basically your slant asymptotes. There's these diagonals right here. Those are like your slant asymptotes. Okay. And then here's your other vertices right there to get your four vertices going out from the center. Okay, so you're going to either have one set or the other, depending on whether x squared is first, is going to open left or right. If y squared is first, it's going to open up and down. Okay, just like your parabola. If it's y equals x squared, it opens up and down. If it's x equals y squared, it's opening left and right. Orientation is either horizontal or vertical. Okay, foci plus or minus c, comma 0. That's again because there's no shift. There's no h. Should have that h and k there. I don't know why they didn't put that in there. So there's starting from 0, 0, the origin. Okay, remember c. You wonder what c is. Again, it's right back up here. C squared is a squared plus b squared, so I have to take the square root of both sides afterwards to get the c. Now, the foci, if you think of these as two parabolas, remember the foci is always inside the parabola. Okay, so it'd be there and there if we're talking about the red ones. Now, if you think about it, remember the foci on the ellipse, let's change the color, the foci in the ellipse are right inside the ellipse, right? So we'd have an ellipse that would look like this right here, right? And the foci were inside. And now it's c squared c squared equals a squared minus b squared. We'll look at where these foci are a lot further out, right? So wouldn't it make sense that I'm going to add them to get a further distance away from the center? These two foci out here, these green ones, inside those branches are further away. So I'm going to have to add them together and take the square root to get that, versus these ones on the ellipse are inside, they're closer to the center. Okay, and the closer they are to the center, just so you know, the closer they are to the center, the more circular it is, remember? So when the foci are at 0, okay, that's when it's a perfect circle. Okay, the closer it gets to the center, the closer it becomes a circle for the ellipse. All right, so that's the major difference. You have a squared plus b squared, which makes sense to get them inside the, quote, parabolas, if you want to think of it that way, or the branches. So you got to go further away. So you're adding them. And secondly, there's a minus sign in between them. So minus sign does matter. So if x squared is first, it opens left and right. If y squared is first, it opens up or down. The length of the transverse axis and conjugate axis, still the same idea as that 2a and 2b. Okay, the equations are the asymptotes. These are these diagonals. Those are diagonal asymptotes right there. Okay. Remember, since it's through the origin, that's why there's nothing afterwards over here. Like it's through the origin is the parent one. It's plus and minus. The plus one being this one right here, and the minus one being the negative one right there. That's why it says plus or minus. Remember, it's changing y over changing x. So which value is underneath the y. The b is underneath the y. That's why you see the b there. Over changing y over changing x. So b over a. Versus this one when it opens up and down, okay, the a is underneath the y, so it's still changing y. What's underneath the y? The a, so the a is on top. What's underneath the x? The b, changing y over changing x. A over b. That's your slope. Okay, remember y equals mx, slope. Okay, so that's a lot of information explained to you there. Now let's go ahead and look at problems here. Write an equation for the hyperbola with center or with the vertices 0, 4, 0, negative 4. And the equation of the asymptotes is y equals plus or minus 4/3 x. Okay, with vertices 0, 4. So technically the vertices are the only, the vertices, if I had my graph back up there real quick, if I had this one right here and this right here, the vertex of each of those are the vertices. So the ones on the ones that aren't here, if I had my box in here again, okay, these are not vertices, those points. The vertices are technically the only ones where the branches are going to be. Okay, by technical definition. But remember, for an ellipse, all four of them are vertices. For the hyperbola, it's just the two that are part of the graph itself, which is the two branches. Okay. So that's going to tell you how it's going to open, up or down or left or right. That's what that's going to help tell you. So if we go ahead and graph this, 0, 4, 1, 2, 3, 4, and 0, negative 4, 1, 2, 3, 4. So that means it has to open up and down because it has to go through the vertices. You have to be part of that branch. So it opens up and down. Then we know it's y squared first, right? Well, what's the center? The center point is 0, 0. So there's y squared minus x squared. And it still equals 1, always for that. And then notice, remember this, the 4 is underneath the y, it's changing y. So that's 4 squared is 16. Or changing x, 3 squared is 9. Okay, because it's changing y over changing x for slope. Remember, so this 4 came from what's underneath the y. Remember, this is a squared. This is just a over b. But this down here is a squared, and this down here is b squared. So I have to square both those numbers. That's why I have 16 and 9. Okay, so there's our equation right there. Okay, so you have to know the setup of it, okay, with this a over b, for example. Or just know that it's changing y over changing x. So the top number goes along with what's, and square that, that goes underneath the y value. The bottom number, square that, that goes underneath the x value. Okay, that's how, to me, it's easier to think of. As long as you know what slope is, changing y over changing x. You should know that from Algebra 1, pre-algebra. All right. So, we have, did they define? Okay, so the definition of hyperbola, let's go back up here. Hyperbola is a set of all points in a plane such that the absolute value, the difference or the distances from any point on the hyperbola to any two given points in the plane called the foci is constant. Okay, that's its definition itself. The difference, absolute value difference, because we want to make sure distance is positive, that's why it's that. From any point on the hyperbola to any two given points in the plane called the foci is constant. Okay, So that distance, I take that distance and that distance, I subtract them. Call that x and that y. X minus y must be the same. Say it comes out to be z, whatever that number is. Now take any other point. Call that w, into the other foci, r. Then r minus w must also equal z. Okay, so the subtraction of those differences is the exact same number as z. Okay, that's what that's saying right there. Okay, that's this definition wise. You don't have to know that to do any of the parts of the problem, basically. Okay, we're going to deal with it all. Okay, that is the front page. Yeah, okay. To graph the hyperbola, okay, from the equation, now they throw in the x minus h, y minus k, etc. Again, it's always going to equal 1. Remember the difference between hyperbola and ellipse, got a minus sign, so the order matters now. Okay, but it's still 1. Okay, completeness square. Okay, get the equation in standard form. Okay, so put the x's together and the y's together. The order doesn't matter. They want to put y squared first. That's fine. 6y squared minus 36y plus blank, and then I got minus 4 x squared minus 8x plus blank equals negative 26. So I know to put the 6y squared as opposed to x squared because they have a minus sign. Okay, with that. So factor out the 6. I'm left with y squared minus 6y plus blank, where it's 0.5b squared. So it's negative 3 squared is 9. Okay, I'm going to factor out the negative with the 4. Negative 4, so I'm just going to make this plus, x squared first. X squared plus 2x plus blank equals negative 26 plus blank. Oops, plus blank. Okay, so half of 2 is 1, squared is 1. Let's change those colors so we see those better. 1 and 9, but don't forget, I really added 54, but then don't forget right here, this is negative 4 times 1, so it's really subtracted 4. So 54 minus 4 is 50, so I really added 50. And 50 minus 26 is 24. 26. Okay, so I complete this now. I have 6 times the quantity y minus 3 squared minus 4 times the quantity x plus 1 squared equals 24. Now what do I do? What I got to remember, it has to always equal 1. So I have to divide each term by 24. Okay, so I'm running out of room down there, so I'm just going to write it up here. Change the color. Write it up here. 6 cancel the 24. So I have y minus 3 squared over 4 minus the 4 cancels. X plus 1 squared. 4 cancels with 24 6 times equals 1. Now I have it in my standard form. Okay. So now I can see my center. Remember, it's opposite. X coordinate is negative 1. The y coordinate is 3. So you do have to pay attention to that. Look, this is the y is connected with the x. The 3 is connected with the y. So there's my center. So I plot negative 1, 3. It's right there. I go 2. Remember, I take the square root of that. I go 2 in the y direction. 1, 2. There's that. That's one vertex. And I go 2 down. There's the other vertex. I go the square root of 6, which is just past 2. 1, 2. Okay, in a little bit. 1, 2, in a little bit. Okay, that's what I do. Draw myself a box. Okay, it goes through that. And then I can draw my diagonals the slant asymptotes to the corners of those boxes. And you see the black dotted line right there, both of them. Okay, and then I know since y is first, it opens up and down. Okay, another way to think of that is it has to go through the y. Both of them have to go through the y-axis. If I open left or right, one or neither may even go through the y-axis. If y is first, both the parabolas or both the branches have to go through the y-axis. Of course, if x is first, both the parabolas or branches will go through the x-axis. Okay, so that's another way to help you remember which way to draw your two branches. Let's not mess that up. Okay. So don't forget, for the foci on these, it's the square root of a squared plus b squared. So I'm going to do 4 plus 6 is 10. C equals the square root of 10. Now, don't forget, now I have to decide, okay, which coordinate do I add it to from the center? Where the center was negative 1, 3. So which do I add? Do I add square root of 10 to the negative 1 or square root of 10 to the 3? Well, since mine open up and down, the foci have to be inside the branches. And so which direction is that when I started the center? I went up. Up and down is the y direction. So I'm adding it to the y coordinate. So the foci would be negative 1, foci, negative 1, and you can say 3 plus or minus the square root of 10. Okay, because you went 3 plus the square root of 10 is one of them. That's the upper one, and 3 minus the square root of 10 is the other one down below. You can write your answer like that. Okay, just so you know, for the two foci. Okay, because it asks you to do that down below here. Identify the vertices, or they have to be on only the two that contain the branches. The foci, we just showed you how to do that, and the asymptotes. So remember, asymptote is the two. It's always going to be, or you're going to still just do it with this first one up here. Y equals plus or minus, it's the change in y. So what did I go for the y? Y underneath y was 4. Square root of 4 is 2. Over change in x, underneath the x was 6. That's the square root of 6. Okay, and that's what it'd be, x right there. My equations, y equals plus or minus 2 over the square root of 6, and then times x for the asymptotes. These ones will probably come out nicer down here when they ask them for the slope of the asymptotes right there. Okay. So if you have to rewatch this or rewatch part of it, okay, this is why you need to learn completing the square. And geometry will be easy. It should be easy for you now. You just add that one extra piece of the factoring out, and then have to remember to distribute it through there. But the completing the square should be easy because we've done it so many times in geometry class. And find the center of the circle. Okay, preparing for the decast on that one. All right, that does it. 18.